All right, Tobit Bhai, over to you.
Thank you, Zaud So, uh, I think few months ago, when Shaun Bhai talked about knowledge sharing from our team, we proposed a different topic. And then a lot of time passed on, and then Shaun Bhai asked once again, what are we doing the same presentation? Meanwhile, I was getting a lot of questions regarding what is data engineering. So I pitched this idea to Shaun Bhai that maybe we can talk about the basics of data engineering so that people who are not doing it gets a first idea of what we are doing actually. So I'm Tovit, and I have been working as a data engineer in DN analytics team for the past 5 years. And for today's data engineering topic, we are going to use these tools, Airflow, DBT, and BigQuery, which we will talk in detail shortly. So today's agenda is we will learn what is a data pipeline. I will walk you through a code base that I've created, and we will learn together. And then I'll go through the architecture overview, also what techs we are using in our stack. Then we will show a live demo, then some best practice, and then finally some Q&A. So to start with, we are building a data pipeline today. So what is a data pipeline? So a long time ago, people started figuring out that data is very important when you are trying to make a business decisions. Like, for example, if you are an e-commerce website, you would like to know which products are selling most, which users are attracted to what. In order to figure out this knowledge and do analysis, they needed data. But unfortunately, when you have a production system, you cannot query on that database directly because that is going to cause issues. So what did they come up with? They started copying the data, which we also call replication, somewhere else other than the production database, and then do a lot of transformation to figure out the knowledge. So data pipeline is basically replicating your production databases or some other sources like APIs, and then putting it into your database or data warehouse, as we call it. And then we do some Pythonic manipulations, or in today's world, we use DBT to achieve these transformations, and then create some aggregated tables from which your BI reports will fetch data. So when we talk about data engineering, extract, load, and transformation, this is very common words that you will see. So what is extract? Extract is the part where we copy the data from existing systems. It can be files, it can be production bases, it can be APIs, and load is loading the data into your warehouse. And finally, transform is manipulating your data to get what you want. And analyzing is like, we can say that it can be the layer where we are exposing the data through reports, or our data scientists doing some analysis on that. It can be a lot of things. And also today we are going to build this production ready data pipeline with best practices that we follow in today's industry. And then we'll see how to deploy this using Docker in one command. For the tech stack, for extraction part, we are going with Python. Python is very popular. I think it's right now the most popular language in the whole world. So the purpose of using Python is pulling data from different APIs and files. Then orchestration, for this, we are going to use Apache Airflow. It's a source tool. It was initially developed by Airbnb, and then it was under Apache Foundation. So it comes with built-in scheduler, and also it has monitoring. So it's really easy to debug your workflows. Then for transformation, we are using this tool called DBT, which is data build tool. It's purpose is to use it as a SQL-based data modeling. And the data warehouse, we're going to use Google BigQuery. It's a really scalable analytical database. And then for deployment, we are using Docker in a containerized environment. If you want to look further into it, you can dig a little deep into Helm and Kubernetes, and then you'll be able to host it in a cloud environment as well. For today's demonstration, we are going to do it locally. So the architecture. As I said, the first thing that we do in data engineering, it's extraction. So when it comes to extraction, there must be some data sources. And as I said earlier, it can be databases, any databases for that matter. It can be SQL database, NoSQL database. It can be CSV files hosted in SharePoint, in Google Drive, in a lot of other places, in Google Bucket S3. And then also we can fetch data from API as well. And for today's demonstration, we are dealing with weather API. And in our extraction layer, we have written some extractors in Python, which will be used to extract data from these sources. So we are trying to use modularized code. We are trying to follow the best practices. That's why we are going with abstraction as well. So we have written a base extractor, and then we have extended that to write a CSV extractor and weather extractor, which will be communicating with the API. And in the orchestration part, in Airflow, orchestration, to understand orchestration, it begins with the concept of DAG. DAG means directed acyclic graphs. So these are nothing but some Python files where Airflow can process the Python files and figure out what task exactly to run. And after that, it also comes with a scheduler. So it will be doing the scheduling for us as well. And then also it comes with a very nice UI, which will be used for monitoring. And also using Airflow, we can send alerts as well. Like you can get emails, or you can integrate your Slack using Slack webhook operator and get your pipeline failures. Then comes the data layer. For data, we are separating it into 3 separate layers. So first layer, we are calling it raw layer, which is also sometimes called landing zones. So we will be fetching the data from the weather API and then directly dumping the data without any transformation in BigQuery. So this layer will be called data layer. And in BigQuery, you will see that we can do logical partitioning of the tables using datasets. In other databases, it might be called schema. So we will build this raw data set under which we will have this table called raw weather data. And after that, the DBT will come into the picture. So once the data is in the raw layer, Python is no more needed. We are going to write sequels. And there are some logical divisions in the transformation as well. So what we are dividing it into is staging layer, intermediate layer, and analytics layer. So staging layer is where we expose the raw data. And also, if we need any standardization, we do that on that layer as well. So, but mostly staging data is very similar to the raw without minimal transformation. When it comes to transformation, and if we want to add any business logics, like for example, we are dealing with weather data, right? And we have, later you will see that our data is for different cities. And let's say we want to say how comfortable is the weather of a certain city. So we can create a metric, right? To measure on a scale how comfortable is the weather. So those logics will go into the intermediate layer. And finally, the analytics layer. This is where we expose the data to our reports, our analysts, and our data scientists. So everyone else will not get access to the raw data or staging data or intermediate data. Everyone who will be using our data products will only get access to the analytics layer. And then Data extraction. For this, we have written some object-oriented Python extractors. As I said, showed in the diagram, there will be 3 extractors, and one extractor will be the most important, which is the weather extractor. This will be an API implementation with retry logic, and then we also have a CSV extractor as well, which is used for file-based ingestion. And then we have also, since we do not have any API keys, we are dealing with mock data. We will see that we will be returning data from a mock class. And then also we will see how to do automatic validation and how to handle metadata. So Airflow. Airflow is I think in the last, it came out about like a decade ago, but it's really popular nowadays when we are doing workflow orchestration. This is the industry standard right now, and this is an open source tool, and this has like a lot of contribution, a lot of development is still going on in Airflow. And one cool feature of Airflow is that it comes with a visual DAG. So the Python code that we are going to write, Airflow is going to extract information from it. It's going to figure out the scheduling from it. Also, it will give us a UI, which is called Airflow Web Server, where we'll be able to see the DAGs. Then it shows distinct dependencies between the tasks, which tasks need to be run first, which is dependent. Everything will be shown in the UI. And also we'll be able to schedule from the UI as well. And then also it comes with real-time monitoring and alerts, and also Airflow comes in with automatic retries when something fails. So in our repo, we have 2 DAGs. So one is called simple demo pipeline. This is not that complicated. This is just sample DAG just to show how the workflow moves on from one step to the other. But our important DAG will be the weather data pipeline, which is where we'll be extracting the weather data and then loading the data to BigQuery. And then through the DAG, we will do some transformation using DBT, and then we'll do some automated data quality checks. And as for BigQuery, this is, if you're not familiar with this, this is a cloud data warehouse provided by Google, and this is serverless. And also it has a cool feature of auto partitioning by date. What does it mean? Like if you have a partition column, like for example, you have a partition column called partition date, and you keep ingesting the data to a specific table, BigQuery will automatically partition the data based on the date value, which is a really important feature when it comes to dividing your data into multiple chunks so that it doesn't get overloaded. And also it comes with clustering as well, which helps with faster queries. Also partitioning helps with faster query as well. Schema auto inference means if you insert data, let's say from a data frame, and you haven't created the table yet and you haven't defined any schema yet, BigQuery will be automatically able to determine the schema from it. So that's called schema auto inference. Also, BigQuery, from people to people, it can vary. Some say it's pretty cheap. It's, I think, $5 per terabyte. So you only pay for what you query. But in reality, what we have seen, if when you are dealing with DBT, you are dealing with a lot of data. You can handle like terabytes of data every day. So if you do any mistakes, it's not cheap. And then for DBT transformation, we will have 6 models across 3 layers. So this staging, intermediate, and marks layer, this is, I think, it's called medallion architecture. Like as you go through each transformation, your data gets better. Like you clean up the data, you enhance the data, and finally you get a better data set. So staging is called sometimes bronze data, intermediate is called gold, and mart is called platinum. So the raw data that we will have, we will clean up that data and we will expose it through this staging table STG weather observations. And then we'll add some business logic and we will expose it as int weather metrics, int for intermediate. And then for our data products, the ready tables, we will have two types of table. One will be fact tables, which will contain, one of them will contain the current status of the weather, and the other table will contain the weather history, like all throughout our data pipeline that we will be running. We will keep it running. We will have this weather history table. So history table is really important when it comes to, if you want to do some historical analysis, like for example, if you are a meteorologist, you would maybe like to know a specific weather pattern for a specific month in a specific city. So fact weather history will help you with that. Also for the reporting purpose, in reports, we usually use aggregated tables. We do some pre-aggregation. You can do aggregation on your BI tool as well, but that is not a recommended practice nowadays because you want to use your BI tool only for showing the dashboards. You do not want to process the data in the BI tool. So we will do the aggregation beforehand through DBT. So one will contain the daily aggregation of each city, and the other will contain the aggregation of the summary of each city. So what are the benefits of DBT? DBT is SQL based. So this, even though nowadays, I think in latest version of DBT, you can write models using Python as well. But initially when it started with SQL only, and it's accessible to analysts who do not know Python. Also, as I was mentioning, that you do not want to write your transformations in your BI tool because it's really tough to version control your transformation. So DBT comes in that place. Since this will be SQL files, it will be stored in GitHub or Bitbucket, and it will be version controlled, which will be transparent. Also, it comes with a built-in testing framework. Like if we are using Airflow and we want to do some testing on the data, we will have to use tools like Great Expectation or their Airflow operators like SQL operators. But the nice feature of DBT is that it comes with a built-in testing framework, like we have in Python, we have PyTest, right? So it's something similar. Also, it comes with auto-generated documentation. So the models that you will write as a code, it will come up as a documentation. Like you see for REST API, we have Swagger documentation, right? So this will look something similar, but in terms of data. Also, it's pretty efficient. DBT can build incremental models, and as I discussed, that we will have a historical table. So historical table will contain terabytes of data. So you will not want to process terabytes of data every other day. So in this case, incremental model comes in pretty handy. So what's incremental model? We only deal with a certain period of data, and then we just append it to the existing data. And then it comes with a lineage graph. So the problem with Pythonic transformation that it's really tough to figure out which data is related to what data. You have to dig deep into the code to figure out, and you will have to go through a lot of data frame transformation to figure that out. But DBT comes with a UI where you will be able to see the lineage graphs. Like for example, when we will build this model, we will see that the intermediate model, it will depend on the staging model. And the fact tables and the aggregate tables, it will depend on the intermediate models. We will be able to see it just from the UI. We do not have to go into the code for that. And then for the deployment, one command to rule them all, we will just do a Docker compose up -d, and it will make the Airflow setup up and running. What it includes? It includes Airflow web server and scheduler. So a long time ago, people used to do this through Airflow CLI by writing commands Airflow scheduler, Airflow web server. But today we will not do that. It will be included in the Docker Compose file. Also, Airflow uses PostgreSQL database as its meta database. So I said earlier that we will be only writing Python files as DAG, but Airflow will parse that DAG and figure out what are the tasks needed to be done, what are the dependencies, and it will put that into a Postgres database. And then the Python dependencies, the Python libraries which are needed to run the pipelines, and then it will also have the DBT codes as well. Also, as I said, Docker Compose up, it will come in with auto initialization. So if we want to see the whole overview of the tech stack, so we'll start with the Docker Compose. The Docker Compose will create the Airflow setup. And Airflow will come with web server, scheduler, and Postgres. Web server, we will be able to use this process to see the Airflow UI. Scheduler will be scheduling the workflows, and then Postgres will be the meta database. And for extraction, we'll be using Python, where we will have extractors and loaders. So extractor will be fetching the data from weather API, and the loader will load the data to BigQuery. And then for the transformation, we'll be building SQL models, we'll be doing DBT unit testing, and then also we'll see the DBT doc generation. And for data warehouse, we'll have data sets, we'll have partition table and clustered indexes. So I think we can move into the demo now. It's a nice time to start. We're halfway through. So let's go to the. So I have included this repository in the slides, so you'll be able to see the code by yourself. You will be able to run it by yourself. I have all the README files ready. And this is to be honest, this is a quite complicated Docker Compose file, so I will not go through this. But as I said, it will come with Postgres, it will come with Airflow web server, it will come with Airflow scheduler. Also, it will come with some necessary volume mounting, which will be needed so that we can expose our code to Airflow. Like if we look at the code structure, all our code will be inside this source directory, and the DAGs will be under this DAGs folder, and extractors like Python extractors, these are under this extractor folder. Loader will be under this loader folder. So we will mount this code into Airflow as a volume. So all of these are done here. So this is taken care of. So let's get started with the DAGs. So a DAG is defined like this. The first parameter is the DAG name, and then we can inject some arguments to the DAG, like for example, depends on past. This is a parameter. This is to tell Airflow that even if yesterday's pipeline has failed, you can run today's pipeline since it's false. So if you want to make it dependent on path, you have to set it as true. Then also start date, end date. And as I said, Airflow comes with built-in retry logic. So if this pipeline fails, it will retry one more time after 2 minutes. Its schedule interval is daily. So this is an Airflow specific syntax, like it has hourly, daily, weekly, monthly, yearly built-in parameters. Also, if you want to run on specific time, you can provide it cron expressions. So if you want to run on a specific minute of a specific hour, you can do that. So catch-up is false means if we do not set up catch-up as false, since the start date is 2024 January 1st, it will try to run every pipeline up until today. So it will trigger almost 700 pipelines. So it's a good idea to set catch-up as false. And in the DAG, this is the interesting part. The dependencies are defined like this. There is also another syntax. I think you can write it as start.set downstream. It works as well. So set downstream and this sign, it works in a similar way. So start is a Python task, which will, I think, print something. It's not that much. And also we have the transformation, load data and send notification. So it will go like this. So if I go to the UI, it will look like this. So you can see that there is, if this view is not for your taste, you can click graph so that you can look into the task dependencies. Like this is exactly what we have in the code, right? Start, extract, transform, load, notify, and then end. So let's try and trigger this. So previously when it was ran, it ran for yesterday's date. So as soon as I unpause the DAG, it started running for today's schedule. And you can see that since there is not too many things it's doing, it's not communicating to any databases or anything. The processes are quite fast. So to walk you through the UI a little bit, you can look at the DAG code here. So this will be exactly this code. And then you can see the details. You can see, if you click on a specific schedule task, you will be able to see when it was queued, when it started, when it ended. You can see all of these details. And if you click on a specific task, like let's click on extract, we'll be able to see the logs from here. You click on logs and you can see that these are the logs created by that Python task. And also, if you want to trigger it manually, there is a button, this trigger DAG. If you click on this, it will automatically start triggering. And one more handy trick that I use, like for example, if we want to, let's say this pipeline was a failure. Let's mark this as failed. And I've got a Slack notification and I have to rerun this pipeline. What would I do? There is a neat feature. I can come here and click on clear existing task and it will clear that specific day's pipeline. So now that we have seen the simple demo DAG, let's get back to our important DAG, which is the weather data DAG. So similar to the previous DAG, we have defined a DAG here as well, and it comes with a cron expression. So it runs every 6 hours. So this cron expression, it tells that to run Airflow every 6 hours. So what we will do every 6 hours, we'll be executing this code. So to start with, you can see that when we are defining DAGs, under DAGs, we have these tasks, right? And every task will be some kind of operator. And the first task is an empty operator. This is just for demonstration. It looks cool in the UI, like you are starting somewhere. But Python operators are really important. So when you want to execute any Python code, you will be using Python operator. Also, it comes with a lot of other operators. Like for example, from on the top of my head, I can say that we use BigQuery insert job operator in our projects. What it does, it fetches if you have data in some bucket, you will be able to load it into BigQuery without writing any Python code. So you tell the operator where is the bucket, you tell it where to store the data, which data set to use, which table to use, and then it will automatically execute the code for you. So there are some handy Airflow operators out there. And also another cool operator is Kubernetes pod operator. So in production, a lot of use cases will look like this. You will have a lot of separate repos. When you have a very large company, you will have a lot of data teams, right? So every data team will write their own code. So it will be really tough to manage it with Python operators because it comes with a lot of dependencies. So you can ask those teams, can you give me a Docker image of what you want to run? In that case, if you have a Kubernetes setup, you can use Kubernetes pod operator to execute those workflows. But for our use case, we are going to use only Python operators. So when you use Python operator, you provide a task ID. And task ID is this one, extract weather data on the UI, what you see. And what it will execute is this Python callable. Also in the task, we have to provide the DAG reference as well. So let's go through this, extract weather data. So this is a Python function that we will be executing when running this DAG. This will be the first task. The first thing that it does, it creates an extractor. As I was saying, extractor will be the code responsible to communicate with our sources. So what does our weather extractor has? It has, we can provide API key, even though we are not going to do it today. Also some other configurations, and in cities, we will be providing some mock data. It comes with its API request methods, and I think it has failure mechanisms as well. Like if it cannot fetch from the API, it will load the mock data. And the mock data will look like this. It will come with city name, latitude, longitude, and for different data, we are going to generate some random numbers, like for temperature, mean, max, pressure, humidity, some KPIs that we can use to measure weather, and then also a timestamp of when this data was produced. So these are that, and we'll be calling this method to fetch these informations. So we will look through all the cities, and we will generate a random data for each city. So I think for now we have, let's see, I think we have 5 cities. So every time we execute this code, we will get 5 rows of data for each of the cities. So once we have the data, by the way, I think we are returning the data as a data frame. So when you are dealing with data in Python, this is a really common library that you are going to use. Data frame is really efficient when it comes to dealing with like thousands of rows. But I will say it struggles a bit if you have like in the scale of millions of billions of rows, right? So in those cases, I think we have to use other tools. We have to go to Spark. We have to use streaming. We have to go to other solutions. But if your data is like, let's say moderate, like if you have 8 to 10 gigabytes of data, I would say it's safe to use data frames. And also, we are going to add some metadata to the existing mock data as well. Like we are going to add these 2 important columns: when it was extracted and what was the extraction source. These values will be shown in the raw data. So once we have loaded the data, we will validate the data. So we are doing a simple validation here. We are checking whether the data frame is empty or not. And then we will return this data frame. So this method will have the data frame. And then what we will do, we will store this data frame as a Parquet file in a local folder. So this will be under this data folder. And it will come with its own file path, and this file path will contain a specific timestamp. So you may ask how. So from extract weather data, when we will be validating data or loading data to BigQuery, we will have to communicate to these files, right? But how will these tasks know what is the file path, where to look for it? So Airflow has a really cool feature for that. It's called XCOM. It is used for communicating between different tasks. Like we can push data through XCOM. Like we are going to push a key called raw data path, which will contain the file path, and also we will push the row count. So whenever we are executing the subsequent task, we will do a XCOM pull. So that will let us know what file we are dealing with. So we have extracted the weather data. The next thing is validate. So as I said, we are going to do a XCOM pull to know what file we are dealing with, and we are doing some data frame checks. Like for example, we will be checking whether this is non-empty, whether it has the required columns, whether it has null city names, whether it has valid temperature range. Like for example, since this is Celsius, temperature of less than -100, this is, I think, kind of impossible unless you are in some sort of simulated environment. And then we are going to validate the humidity as well. So once we have done the validation, we will raise a value error if one of these checks failed. So every step of the way, you will see we will validate the data, we will load the data, and we will, once again, when it comes to DBT, we will load the data, we'll validate the data. So this is a really important practice in data engineering, that you do your data validation yourself, because this is not a traditional field of software engineering where you have the support of QA. So unless you have these checks in place, there is a high chance that you will be pushing wrong data, and one of the user of your report will come screaming at you. So do it at your own risk. Do your data validations. And one important tool that I want to mention when it comes to data validation, since we are dealing with data frames, and data frame is quite fast, we are doing data frame checks, but these are not clean in my sense. We can use Pydantic. Like Pydantic is a library which can be used to do the data validation, but it will be kind of slower because in data frame you are dealing with a lot of rows at once, and it has like it's built using Python, I think, so it's quite efficient. But Pydantic, it will be loading your data into each model and will do some validation on each model. It will be slow. Like let's say if the data frame manipulation is in the order of millisecond, probably your Pydantic model checks will be in the order of seconds, but it's much cleaner, I would say. So you can check that tool out as well. It's pretty cool. And after we have validated the data, we will move to data loading. And we have written, as I said, we have extractors and we have data loaders as well. So this method will be communicating with this BigQuery loader. And we'll be using this load data frame method. We will be providing the necessary parameters. Like for example, when you write to BigQuery, it's necessary that you provide the dataset ID, table ID, and this write disposition. This means how you deal with data for an existing table. Write append means for an existing table, you are going to append to the data. There is another option called write truncate. And if you use that, it will override the table every time you run this pipeline. So I will skim through this part because I think we are running short and we have to cover DBT as well. So let's say we have a Python code which can write to BigQuery. And then we have this task group. This is another feature of DAG, that you can group your Python task as well. So you can click on expand. So if you don't want to look at this, like for example, you don't want to look at this frequently, you can use this task group, because within this task group there will be multiple tasks, and if there is any errors, you can expand this and have a look at what's going on. So when it comes to DBT, you have to run some DBT commands, and some of these commands are like DBT deps. So I think maybe we can go through the DBT project at first a little bit. So when you have DBT project, you will have to write this dbt project.yaml, which contains your DBT project representation. And the most important configuration is model paths, because you will be writing a lot of models, and you will see that we have a models directory in here as well. So these will contain all your SQL models, and spoiler alert, this is what your models is going to look like. And then we can have a test directory as well. Also, seeds is another cool feature. Like for example, when you have static data and you want to expose it as a table, like for example, let's say you have a BigQuery table which picks up data from a Google Drive file, which is used by your analysts. And analysts sometimes edit those files and add a row, and that is synced to BigQuery. So what is the problem with this file? You are not having any version control, even though like in Google Drive, you can have version control, but this is not traditional version control we are talking about. You can replace those Excel files with seeds, and you can do your Git version controls. And then macros are reusable SQL codes. So these are, we will have a macros directory where we will have like Jinja templating, where we'll be able to reuse these codes. And then snapshots is, I think, not important right now. Let's go through the important stuffs. And when you have, you can provide a general configuration for your models from this DBT project. And this is done through, since this DBT project is called Weather Analytics, and these configurations are under Weather Analytics. That means all of the models will inherit this configuration. In DBT, what we do under models, you can see 3 folders, right? We have folder-based logical partitioning between the models. So STG weather observation, this is one model. Int weather metrics, this is another model. So what we essentially want to do is, through these sequels, we will be generating BigQuery tables. And as I showed in Python code, in BigQuery, you have to tell which schema to use, right? So how do we tell that? We can provide this parameter schema. And since this is under Weather Analytics, all of these models will inherit this property. So if you do not override it in the model level, your staging schemas will always go under this staging data set. Your intermediate models will go under intermediate data set. I hope it makes sense. So another way to override this setting is to use this schema.yaml. So remember, we have already written to a BigQuery table using Python. So we have to expose that table to DBT, right? How do we do that? We have to use these sources. And for sources, I think if I go to UI, it will be quite useful. So raw data, you can see that we already have some data in here ready. And these are the raw data written by Airflow Python pipeline. And in order to expose it to DBT, we are going to use this sources configuration. And under schema, you can see we are trying to read from an environment variable. If it's not provided, it's picking up a default value called raw, which is exactly this data set. And for table name, you can see it's weather data, which is this table. So when we run this DBT, command, it will be able to pick up this table, and in DBT, it will be referenced from this source. And in here, you can see all the same thing that we have here, all the column names, city name, latitude, longitude. We have defined all the column names in here as well. Also, you can see that we have written a test as well. So what it means, when we try to load this data into DBT, it will automatically run this test and check for whether the timestamps are not null. And if it's not null, it will throw an error. So that's why I was telling that DBT comes with its built-in own unit testing, which is done here. And now let's go through a model. So after we are done with this model, what we would like to achieve is we would like to create a table under this staging dataset, which will be called STG weather observation. And we are providing some configurations there. Materialized view means it will be created as a view. So it will not be a, I think the font might be a bit smaller. So let me increase it. So it will be exposed as a SQL view. So you can provide another parameter called table. Then it will be a physical table, which will be occupying space. But in this case, this will only just be a view. And what data it will contain? It will pick up data from this source, raw weather data, which is reference to this source. So that means when we execute this SQL, it will read data from this raw layer, which was written by Airflow. And Airflow has left the chat. It's not working here anymore. We are working with DBT right now. So we will load this data as source data. And later, as I said, in staging layer, we will not do that much manipulations. We will do some simple manipulations, and also we will do some like typecasting, this sort of stuff, and some really simple stuff. Like, for example, we are converting the temperature, which was in Celsius, to temperature Fahrenheit. This is not that complicated, so we can put it here. And finally, what we will do, so as I said, we will be fetching data from a weather API periodically for every city. So that means there will be multiple rows for each city every time we trying to look at that. Like you can see for London, we have 2 rows. So for further analysis, we need to know which is the current row, which is the current active row, right? So that manipulation is being done here in this part. We are grouping the data by its observation timestamp, and the row with the highest observation timestamp will get a is current value as 1, otherwise it will be false. So this was raw data. That means it will not have any is current, right? Because Airflow did not have add any of this. Airflow had only some mock data, and remember we added some metadata, extracted at and extraction source. So after we run this DBT model, we will end up with this. And you saw that if you have a physical table, you can do preview. But in BigQuery, if it's a view, you cannot do preview. You have to run some SQL to get the data. So you can see in here, we have added an additional column, which is a surrogate key of city name and timestamp. You can see that as observation ID here. And finally, we have the is current column, which is telling us which is the current active row, which was done using this portion of the code. So now that we have the staging model ready, we are ready to expose this data to our analysts so they can build these intermediate models. So in intermediate models, we will be adding some business logics. And finally, it will be exposed as a view as well. In BigQuery, you can see that it has a distinct icon, the view, and the physical table, it has distinct views. So in intermediate, you can see here as well that this is a view as well. So for creating this intermediate model, we will be referencing the staging model. So for the staging model, we were using the raw table. And for the intermediate model, we will be using the staging model as the data source. And you can see that we are implementing some business logic. Like, for example, we are trying to calculate the heat index. We are trying to calculate whether the weather is comfortable or not. We are trying to determine whether the weather is dry or comfortable. We are measuring the air pressure, then also some wind metrics, blah blah blah, and then finally, as I said, we are going to do a nice calculation of comfort score. So all of these are done using SQL. So you can do the exact same thing in Python, but as I said, it comes with a lot of drawbacks. So finally, when you do this select star from calculate metrics, it will be projected into this int weather metrics table under this intermediate data set. And where did it pick up this config that this will go inside this intermediate data set? You can see that we haven't told it that which schema to use, right? We can override here, but it's picking up from this global config from DBT project. All the intermediate models will go to intermediate data set unless you have overridden here. So we have, let's see what the int weather metrics contain. Since this is a view, we cannot preview the table. We have to run a SQL query to see the data. And you can see that, let's just see, we have some category. You can see this. I wanted to show you this column, comfort score. This is a derived column that we built using DBT. And then finally, we can use this intermediate table to build our data products. And as I said, we will have two types of table. One will be fact table, which will be used for further analysis, and one will be of aggregated type of table, which will be exposed to the dashboards. So for aggregation, we will do some just simple round average or min max on the intermediate tables and expose them as a metric. And this city summary, it will contain only 5 rows of the latest average data of all the cities. Right? And I can show you it in demonstration. It will go inside this analytics directory, aggregated city summary. It will look like this. It will only contain the 5 rows of all the average of all the historical data. Otherwise, remember what you would have to do. You have to go through this fact weather history table and do aggregation. And this table is huge. This will require a lot of compute power. We are not going to do that. We are going to expose it through the aggregate city summary table. So yeah, and then this another aggregated table. So one of the a required feature usually in BI dashboards is users want to see the data in daily aggregated levels, and we are going to do exactly that here. So you can see that the materialized type is different here. It's going to be exposed as a table. Otherwise, when your BI tool executes the query, if it's a view, it will be querying the staging table, the intermediate table staging table once again. So we will be preparing all the data for our dashboard, and it will be exposed through a physical table. And then we are doing some aggregation here as well. But the difference with the previous aggregation is that we are doing aggregation on a daily level, right? So you can see that we are grouping by 1, 2, and what is 1, 2? One is city name, 2 is observation date. And if you look at the data, it will represent exactly that. And also importantly, you can see that it's saying that it's a partition table, right? So we haven't seen this before. So this table is partition based on city and city name and observation period. So this was ran for previous 2 days data. That's why you see this kind of scenario. So you saw that this pipeline was supposed to run every 6 hours. So every 6 hours, if you run this, you will be able to see if a new day comes up, you will see a new observation date coming up. And then the fact tables, the first fact table, it will be exposing the current state of the weather. So this is pretty simple. It will be reading only the is current true column from the intermediate table and then just simply exposing it to a fact table. You can say that we can easily expose it. Why don't we just expose the intermediate weather matrix? The answer is the intermediate weather matrix might have a lot of data that is not needed in the BI or some sensitive information that we don't want to expose. So that's why we will be exposing only these fact tables with the specific columns that we want to expose. And the history, it will be an incremental model and it will be right appending to the existing table for future analysis. I had to skim through all of this because we do not have much time. I am really sorry for this, but you can look through the code. And finally, I just want to cover some final notes. Like some of the best practice that we demonstrated in this demo is separation of concern. Like when we say ETL process, nowadays it's also ELT is very popular. Like you do the extract and load first. Like using Airflow, we did extraction through the Python script and then load using the Python script. And then when it comes to DBT, it's only handling the T of ELT, the transformation part. And we have written modular and reusable components. For data quality, we are doing tests at every layer. We are doing validation before and after each transformation. And then for observability, we have built-in Airflow logging. And we have monitoring and then task level tracking. And task level tracking means we can see which task is dependent on what. And this solution is pretty scalable as well. So these tools, these are Airflow and DBT, these are cloud native. BigQuery, you can replace it with anything of your choice. And BigQuery comes in with partitioning and clustering, which helps with scalability. Like you can process terabytes and terabytes of data with the help of partitioning and clustering. And then you can have incremental loading in DBT, which will help you with handling a lot of large tables. And for further reading, the repository is open. And then also you can go through the Airflow and DBT documentation for further reading. That's it from my side. Yeah, I have to drink some water. I think
All right,
if you
guys,
haven't,
does anybody have any questions for Tawhid Bhai?
Yes, I do have one.
Yeah.
Yeah, myself, Sunny, and my question is, as Tohid Bhai just mentioned, that there are two terms, ETL and ELT in data engineering. So here in this session, we have just seen that you demonstrated how ELT works. So it would be great if you could explain or just have a small example in which case we should use ETL and ELT.
Actually, we have not demonstrated ELT here. We have demonstrated ETL because remember, we were doing extraction, then loading in the BigQuery first, and then we were transforming the data in using DBT later. So I would say my personal choice is ETL over ELT because you always want to process your data as close to your source as you can. But when you do ELT, what you are or ETL, what you are doing, you are extracting and then transforming and then loading. So you are doing all the processing in your compute and then loading the data, which is far away from your source, which is your database, right? So ideally, you would like to use SQL and run your query on that database. So that database handles the compute, not you. So that's why I would say ELT is better than ETL. So first you load the data, then do the transformation. I hope that answered your question.
Yes, absolutely. And bhai, I have another one, which is as per the data engineering task is we complete the ETL or ELT, whatever it is, and then the analyst starts working on top of that. As you just mentioned, you do the raw data, extract the raw data, and get the aggregated data and all other things. In this session, you just demonstrated the zero to the final product. So in which case actually in this case do you absolutely do the all of this task, or in some places you just let it done by the analyst?
That's a really good question, I would say. The reason of using DBT is DBT handles SQL, right? And a lot of analysts are comfortable with SQL, but they're not comfortable with Python. So if you want to involve your analyst more, you have to go to SQL, and that's where DBT comes in. So if you have DBT set up, then it's really easy for your analyst to come in and contribute. But definitely before that, you have to put some conventions. Like you saw a lot of folders, right? You saw intermediate layers, you saw staging layers. So once you have this setup ready and you have the conventions ready so that you know exactly where to find things, I think it's easier for analysts to get started. But I think for starters, like if you want to set up DBT, if you want to set up some CI/CD, which will automatically run DBT once you have merged your DBT code, in order to set that up, I think the data engineers need to be involved. And once the project is ready, analysts can come in and contribute from the DBT part.
Yes, I got it. Thanks.
I think there was a question in the chat box from Sohanul.
Sohanur asked, what is the maximum size of data that can be processed through XCOM in a specific DAG, and how should we handle larger data that needs to pass? That is a really good question. The rule of thumb is do not send files through XCOM, only send some metadata so that you can use that metadata to figure out where the file is, and then you can read the file from the next task, right? I do not remember the exactly same size, but I do not think it's recommended that you send data more than a megabyte. I don't think that would be recommended. And in those cases, as I said, I was storing the file locally. So one approach that we do in production, we use buckets. So from extract layer, we will be storing the file to a bucket, and we will be through XCOM, we will be pushing the information where is the file. And the next task, when it comes the load part, it will XCOM pull and it will know where the file is, and it will read the file from the bucket. So in order to communicate through large files, you need to use some sort of file-based solution, and in your case, it can be buckets. Thank you, Nazmul Bhai. Any other questions?
I have one question regarding the architecture. So you mentioned that the medallion architecture here, but in the BigQuery, I can see there are four distinct tables. One is row staging, intermediate, and another is analytics or mart something. So according to the medallion architecture, there are four layers. Bronze, silver, and gold. So how can we map with that with the query?
Yeah, I'm not sure. Like I think I read something about a 4-layer medallion architecture as well. So when you have bronze, silver, gold, and you can add platinum as well. So in our case, we can map it with raw data is the bronze data, and then the silver data is the staging, and then so on and so forth. And also there is another logical definition as well. Sometimes we can divide the staging and intermediate layer into silver as well. In that case, we can use the 3-layer medallion architecture as well, because in the intermediate layer and staging layer, we can say this is not either raw data, this is not ready data either. So we can put it somewhere in the middle.
Okay.
Anyone else? I think if there is no more questions, I think we can conclude.
Yeah, all right. I think there are no more questions. There are no more questions in the chat box either. Well, thank you everybody for joining. Thank you, Tohid Bhai, for the wonderful session. And as always, the video recording and the slides will be present in the repository shortly. Everybody can check it out there. All right, everybody. Have a great rest of the day. Thank you for joining. Bye-bye.